Here's another video in my efforts to start posting on YouTube again. Working on the chicken, and I want to talk a little bit about fixturing and what it takes to do a good fixture and some fairly complicated fabrication. Now, a fixture is different than a jig. I posted this on Instagram the other day and got a lot of comments. So jigs and fixtures are not the same thing. A jig guides a tool. So you may have something that guides a router or guides a drill bit to drill a bunch of holes through a bunch of different things. Those are jigs. It guides a tool. And a fixture holds something in place while you work on it. That's the difference between the two. Now, all this black metal here, this is all part of the fixture. Using the fixture to hold 16 of these ellipses all in the right position. They need to be spaced front to back the right way. They need to be rotated the right way so the major and minor axes are perpendicular to the ground plane, and they need to be tilted the right way. If I come in here perpendicular, you can see that these are tilted out and back and forth. The way to do that is not to get a dozen friends to hold this in place while you tack it. For that, you need a really good fixture. So I'm going to describe this particular one. We start off bolted to the concrete here, a piece of 2x4 box tubing. I think I did quarter wall on that. Yeah, quarter wall. Some 1/2-inch plate that I had left over, so that's bolted in. And then just a couple outriggers to make it a bit more stable, and also bolted in point in the middle, and at this end back here another set of outriggers. And this allowed me to clamp all the rings in, but one of the problems is these rings are all bent every 4 inches, and I fabbed up these clamps. Piece of 2.5 box tubing, some of my favorite size material to work in. I used to get a lot of it from a friend of mine in Portland who had 5-foot drops all the time, so it still makes me smile to use this size. Some 1/2-inch or 1-inch angle iron, and these are drilled through so that the ellipse passes through there and gets sandwiched in here, and to hold it in place. And these were really beefy. Clamping down on these guys, you couldn't get this to swing. But one of the problems is I couldn't take this piece all the way to the ground. And the reason is where it clamps onto the tube here can vary, and I may have a high side of the bend or middle section, or low side of the bend and a middle section, or both on a middle section. This is 2.5, so it could have fallen anywhere. I needed a way to twist the ellipse from where it's being clamped in order to make sure that the major or minor axis, because it does change, major axes are vertical here, the major axes are horizontal in the middle, and there's almost a near circular ring in there that transitions that. So what I did is took this guy and I clamped it in here, and then I used a plumb bob. Ancient tool, still incredibly useful. So I've got little black tick marks there where the major minor axis lies. I could tie a plumb bob to there, bring it in to here, and that plumb bob might be hanging offset here. I could twist the whole ring so that those tick marks line up with each other, and I could twist it because it's only clamped in right here. Once I had those vertical where I needed to, I could weld those in place. And if you look down the line, it's kind of hard to tell, it probably won't show up on camera, but each one of those is just twisted just slightly, but it does make all those axes all in a straight plane that way. So now I have these 16 ellipses or ellipsi. I'm not sure what the plural is. They're all in place, they're all tilted, they're all ready to go. First thing, and I started with the most complicated ones because I wanted to get them out of the way, are these beautiful curved compound sides. Compound meaning they're not just bent on one plane, they're bent in multiple planes. You can see this one curves in this way and then it curves out that way. Really tricky bends, and I'm mostly working by myself on this. So what I did is I fabbed up a whole bunch of these. I had access to a plasma table. It's actually just right over there. So I cut out a bunch of these little guys and I could put those on here. And actually I left one in to show you guys. I could put those on with hose clamps, and I lined up all of them. All of these had one of those little hook pieces in there, and that helped me visualize the curve and do my bends accordingly. And a lot of the bending was done. I started with the computer, knowing which angles I needed to map the curvature to the 3D model, but there's also a lot of art into that too, so I could get the base curve kind of figured out and then come back and make adjustments in order to kind of see through here. Oops. Make that smooth curve all the way through there. So I've got these little hook pieces in. I could work on a section, fit it in, see how it fits, and then when I was happy with it, hose clamps again. I don't get too many uses out of them, maybe 5-6 times before they start falling apart, but that's all I need. Now these ones are all tacked in. Actually, both sides are totally tacked in, ready to be welded. Splice joints, trying to keep smooth transitions in the splices. I think this is inch and 5/8. I put a little tack weld on either side so it wouldn't slide into the tube, and I could fit that in there. The tack welds kept it from dropping down in, and then gapped it just a little bit so I could tack weld these guys in. Full pen welds, which is nice. And then I also have these little V blocks that I made up at one point. Those V blocks will keep those lines, so those clamped in there make sure that this is a smooth transition across there and they're not offset. So anyway, these are the first 2 side curves in. Like I said, they're the more complicated of the 6, and I'm gonna start welding them all in right now. Anyway, thanks for watching.